Build skills with experts anytime, anywhere. Get certified, get ahead. The world's largest selection of courses, affordable online courses and learning opportunities, top categories.
Industry-leading data visualization tool. This course is part of our path to the Tableau Desktop Specialist certification. In this course, you will learn about the new data model and differences between a live connection and a data extract. Some of the major topics we will cover include understanding the differences between a logical layer and a physical layer, learning when to use a live connection and an extract, and finally, we will learn about new and available storage options for extracts. By the end of this course, you will have the skills and knowledge of connecting to and preparing your data in Tableau in order to get the most out of Tableau's fast data engine. Before beginning the course, you should be familiar with Tableau Desktop's primary purpose and the general use of the interface. Having basic analytics acumen will help, but by no means is required to be successful with this course. From here, you should feel comfortable diving into Tableau with courses on modifying data connections, managing data properties, and creating basic charts. I hope you will join me on this journey to prepare for the Tableau Desktop Specialist certification exam with the Tableau Desktop Specialist Connecting to and Preparing Data course at. Before beginning this course, you should be familiar with Tableau Desktop's primary purpose and the general use of the interface. Having basic analytics acumen will help, but by no means is required to be successful with this course. For the purpose of this course and the demonstrations within, I will be using Tableau Desktop 2021.1. If you are using an older version, most of the concepts taught in this course are still applicable. You might just not have all of the new and available functions. And finally, download the exercise files so you have all of the files used throughout this course at your fingertips. Let's take a look at what we will cover in this module. We will talk about what a data source is and how Tableau queries the data via the structure of the data model. We will cover differences between a logical and a physical data layer. We will also talk about differences between a live connection and an extract. We will then cover what the different types of live connections are and how you can connect to them. We will then cover new and available storage options for extracts. We will finally go over a few use cases and describe scenarios when it would be appropriate to use a live connection versus an extract. Let's talk about what a data model in Tableau is and how it can be created via the data connection pane. Before we jump into Tableau's data model, let's first understand what a data source is. A data source is a connection to a database or a location where data is stored. You can also save a data source to a file in Tableau. Tableau calls this file a .tds file extension, indicating that it is a saved data source. We will talk about this file extension in a future clip. Let's now talk about how Tableau connects to data. Every data source that you create in Tableau has a data model. You can think of a data model as a diagram that tells Tableau how it should query the data in the connected database tables. The tables that you add to the canvas in the data source page create the structure of the data model. A data model can be simple, such as a single table, or it can be more complex with multiple tables that use different combinations of relationships, joins, and unions. The default view that you see in the data source page canvas is the logical layer of the data source. You combine data in the logical layer using relationships, which is also depicted in this example by noodles. This layer acts as a relationship canvas in the data source page. Relationships are a flexible way to combine data for multi-table analysis in Tableau. We will learn about relationships and joins in a future course. You can double-click a logical table to open it and see its physical tables. Physical tables can be combined using joins or unions, which we will cover in a future course. In this example, I double-clicked on the returns table and noticed that returns table is a single physical table without any joins or unions. This is different in comparison to prior versions of Tableau, where data source only consisted of a single physical layer. In this example, the blue container represents previous versions of Tableau, where you see that the model only has the physical layer. Whereas in the green container, which is the layout in the newer versions of Tableau, you can add multiple tables and relate them to each other. Tables at the logical layers are not merged in the data source. They remain distinct and maintain their native level of detail. We will talk more about the grain of the data in these layers in a future. Now that we have an understanding of what a data source is, how Tableau queries their data via the data source page, let's talk about differences between live connections and data extracts. In Tableau, there are two ways you can connect to your data. The first is a live connection, which means you're connecting to a data source that contains direct connection to your underlying data. When you're connected to a live data source, Tableau directly performs queries against the database in real time or near real time. On the flip side, an extract is a snapshot of data that can be set to refresh on Tableau server. An extract can be created from a static file like an Excel or a CSV, or it can contain data from relational databases or from cloud-based data. An extract uses Tableau's data engine to perform analysis. Extract is also a word that you're going to hear a lot in this course. Live connection is depicted by a cylinder icon, and extract is depicted by a double cylinder with an arrow icon. In Tableau, live connections can be file-based, meaning you're connecting to an Excel file or a CSV in real time. Similarly, live connection can also be used on a database where data is stored. Live connections offer a few advantages and a few disadvantages though. Let's take a look at them. Live connection helps provide real-time or near real-time updates to your data when there is a need. And this is because you're directly connected to your underlying database when using a live connection. If you work with a fast database, live connections may come in handy because it doesn't take too long to query the underlying database. However, there are a couple disadvantages. If the underlying database is not fast enough or optimized, you may not have a great time with a live connection because it can slow down workbook performance. Now that we have talked about live connection, let's take a look at what an extract is. An extract is a snapshot of data that you can use to improve performance or to take advantage of Tableau functionality that is not available or supported in your original data. This snapshot of data is then loaded into Tableau's in-memory data engine where it can be recalled quickly to be queried for visualization. Tableau uses the .tde or .hyperfile extensions to denote that you're using an extract. Hyper is Tableau's in-memory data engine technology, optimized for fast data ingest and query processing on large or complex datasets. You can configure your extracts to tell Tableau how it should store and limit the amount of data in your extracts. With the introduction of logical tables and physical tables in the Tableau data model in version 2020.2, extract storage options have changed from single and multiple table to logical and physical tables. You can choose to have Tableau store data in your extract using either logical tables or physical tables. Logical table stores data using one extract table for each logical table in your data source. So what this means is that if a data source was made of two logical tables, each containing multiple physical tables, then the extract data would be stored in two tables, one for each logical table in your data model. On the other hand, physical table stores data using one extract table for each physical table in your data source. This option can improve performance and help reduce the extract size. To store your extract using the physical table options, these conditions must be met. All joins between physical tables are equality joins. Data types of the columns used for relationships or joins should be identical. No pass-through functions can be used. Physical tables also don't allow for incremental refreshes to be configured. And you cannot configure extract filters. There is no top-N or sampling configuration settings. If your data source meets the conditions outlined in the prior slide, here are some tips that Tableau suggests that you use for physical table option. Use this option if the size of your extract is larger than expected. To determine if the extract is larger than it should be, the sum of the rows in the extract using the logical table option must be higher than the sum of rows of all combined tables before the extract has been created. If you encounter this to be your scenario, try using the physical tables option instead. Because the extract filter option is disabled when using a physical table option to store your data, you can use custom SQL to limit the data and bring in only the data that is required. If you have write access to your database, you can define a view DDL or data definition language that contains just the data that you need for the extract. Let's now talk about a few advantages and disadvantages of using extracts. When you use an extract on a large database, you are using Tableau's in-memory engine as opposed to a slow underlying data source, which results in an improved performance of your workbooks. Extracting data also allows you to use Tableau functions like certain calculations, for example, that might not be supported by your underlying data source. I love that extracts provide offline access to your data, which makes it easy to work on projects on a plane or at a beach. You are able to hide unused fields, which not only helps optimize extracts, but also helps ensure that people only see the data you need them to. On the flip side, let's now talk about some of the disadvantages of using an extract. If your data source contains too many columns, extracts can take a long time to refresh. If you're saving your extracts locally, it can take up storage space. Extracts aren't secure because you're essentially moving data out of your database and into Tableau's in-memory data engine. You can then share the .hyper or .kde file with someone in your company who shouldn't have access to the data. So keep this in mind. Now that we have talked about advantages and disadvantages of each types of connections, let's talk about use cases of when you can use each type of connections to get the most out of Tableau's fast data engine. You would use a live file-based connection if you're collaborating on a spreadsheet, for example, that is saved on shared drive and you need real-time updates. And server-based live connection if you need real-time updates on how your business is performing. On the flip side, you would use an extract if your data doesn't change much. Extracts also allows you to use Tableau's functionality that may not be available or supported by the original data, such as ability to compute count distinct. And extracts are a great way to use when privacy isn't a concern. Let's jump into Tableau and navigate through the data pane. Before you can build any type of data visualization, you need to connect to your data. In this clip, we will go over Tableau's data connection pane. When you first launch Tableau, this is the view you see. On the left is the Connect pane, where you can choose a variety of data connections. The topmost section allows you to choose file-based data like Microsoft Excel, text files, JSON, PDF, and more. You can also connect your data to a server-based connection like MySQL, Amazon Redshift, Snowflake, and more. You can use the More option to see available connections in Tableau. There are also saved data sources that you can leverage in order to make a connection to a source that you have saved in the past. Tableau ships with the Superstore dataset, which can be accessed from this section. This is the .tds file that I talked about briefly in a prior clip. .tds, or a saved Tableau data source, is especially useful if you have added joined tables or custom fields, such as groups, sets, or calculated fields, and need to share this data with your colleagues. You can save a data source to either a .tds or a .tdsx format. .tds file only contains the information you need to connect to the data source, including a data source type, connection information like database server address, port, and location of files. It also contains information like groups, sets, or any calculated fields that you might have created, and any default properties that you might change like aggregation, number formats, and sort order. This format is helpful when you want to share with people who have access to the underlying file or database. However, you can save a data source in a .tdsx format when you have a need to share this with people who do not have access to the underlying data. Because a .tdsx file contains all the information in the data source or .tds file and a copy of any local file-based data, it is essentially a single zipped file. Let's now create a .tds file. Here I'm navigating to the Superstore Excel file saved on my Tableau repository. As soon as you make the connection, this is the window that appears. You are then able to drag tables and queries if you are connected to a database into what Tableau calls a canvas. Here I'm simply dragging the orders table to the canvas. Because saved connections preserve sort orders and calculations, here I'm changing the sort order of the order date field and writing a calculation by clicking on the arrow of the segment field and selecting Create Calculated Field. I want to create a Boolean field that gives me a true or a false value for when a segment is consumer or not. When I then click OK, you see that a new column is created with my new calculated field. If you then click on Sheet 1, at the top of the data pane, you can right-click on a data source and select Add to Save Data Sources. By default, Tableau saves the .tds and .tdsx files to the Data Sources folder under your Tableau repository. Here, let's rename our saved data source. I'm calling it Puja Data Source. And if you notice, the format that I'm saving this data source in is .tds, which you can change to .tdsx. Let's click Save. If I then go back to my Connect pane, you see a new saved data source that I can now use in the future to create visualizations. If you click on it, and then click on Edit Data Source, you will notice that my sort order for the order date field and my custom calculations are both preserved and reusable. So this is how you can create, save, and share .tds or .tdsx in Tableau. Let's talk more about the Connect pane. On the left, you will see different information depending on the type of connection you're making. Because I'm connected to an Excel file, I see different sheets within my Excel worksheet as tables, namely order, people, and returns. I also see named ranges for orders, people, and returns tables. If you are connected to, let's say, a database that your company uses, you will see options to select database, schema, and tables within the schema. If you notice, there is an Add button, which you can also use to bring in other connections. If I click on it, it shows you that you can add new connections to use cross-database joins. You can toggle between sheets and data sources from this bottom leftmost spot on your Tableau workbooks. In the next clip, we will learn how you can use live connections in Tableau. Now let's connect to data using a live connection. In this clip, I'm going to show you how you can use live connections in Tableau. Let's make a connection to a file-based data source. In this case, I am connecting to the saved Tableau data source, Sample Superstore that ships with Tableau. If I go to the data source pane, you will notice the noodle layout that we covered in a prior clip. This is what Tableau calls a data model. A data model is essentially a diagram that tells Tableau how it should query the data in the connected database tables. The tables in the canvas create the structure of the data model. Like we covered earlier, the default view that you will see in the data source page canvas is the logical layer of the data source. You combine data in the logical layer using relationships, also depicted by noodles. This layer acts as a relationship canvas in the data source page. Relationships are a flexible way to combine data for multi-table analysis in Tableau. We will learn more about relationships and joins in the next course. When you double-click a logical table, you will see its physical tables. Physical tables can be combined using joins or unions, which we will cover in a future course. In this example, I double-clicked on the people table and noticed that the people table is a single physical table without any joins or unions. To navigate back to the previous view, you simply click on the Close button on the right. Alright, let's now talk about live connections. Here, if you notice, I am connected to this saved data source in a live format. What this means is that any change that I make on the underlying data will be reflected on my workbook in real time. So let's test this out. If I toggle to Sheet 1 and double-click on the row count on the orders table, I see that we have 9,994 records in the orders table. Now let's change the number of records on the underlying Excel file. Here is the Sample Superstore dataset that was saved in my Tableau repository under Data Sources folder, because that is the default location of .tds files. you will notice that I have the same 9,994 rows of data in this Excel file. Let's go ahead and delete a few records and click on Save. Let's go back to the Tableau workbook and click Refresh on the data source. You will now notice that my row count went down from 9,994. It is also worth pointing out that live connections are denoted by a single cylinder visual cue, as you can see here. Similarly, you can make a connection to a server-based data source and expect the same behavior when you are connected to a live data source. When the underlying data changes or updates, those changes will be reflected in your workbook in real time or near real time. If you navigate back to the data sources page, you will notice there is a filter option that allows you to limit the data you bring in while connected live to your underlying data source. This is especially useful if you're trying to limit data and do development work in Tableau to speed up performance. You can click Add, and a data source filter window pops up that you can use to add filters. As an example, I am adding a filter on the category field to limit it to only furniture. You can also add multiple filters to narrow down the data you want to bring in. If you click Order Date, you will notice that Tableau gives you a deeper option to narrow down on dates. You can choose a specific date or a specific date part, like years, quarters, or months. If I click on years, it lets me choose from the available years of data. Let's choose 2018 and click OK. You will now see that Tableau is connected to my underlying data in a live connection that keeps the rows where category is furniture and order date is 2018. So that is how you can connect your data via live connection in Tableau. And now we will go over how you can create and use extracts in Tableau. Alright, in this clip, we will learn how to create and use Tableau extracts. Extract is a word you're going to hear a lot in this course. An extract is a snapshot of data that you can use to improve performance or to take advantage of Tableau functionality not available or supported in your original data. Tableau uses .tde or .hyper file extensions to denote that you're using an extract. In this example, let's toggle from live to an extract. As soon as you change the toggle, it tells you that Tableau will include all the data. If you click on the Edit button, you will see a configuration window appear. As we talked about in a prior clip, the default data storage format that Tableau uses is logical tables to store the data. In this section, you can specify how much data you want Tableau to extract. Similar to how we added filters when we were connected to a live data source, you can add filters in this section to limit the data you're trying to bring in. Use the aggregation data for visible dimensions to roll up measures using their default aggregation to consolidate rows, improve performance, and reduce extract size. You can also optionally further roll up dates to specific date parts like year, quarter, month, or day. Use these options here to select number of rows that should be refreshed in the extract. The Extract History pop-up will show you the history of your refreshes with information like time of refresh, action, like whether it was a full refresh or a partial refresh, number of rows that refreshed, and the source. You can also hide unused fields to reduce the size of your extracts. Now if I click on Sheet 1, Tableau is asking me to choose a location to save my extract. Here I'm typing the name of my extract and choosing my desktop as the location, and clicking Save. If you now notice, we went from one cylinder to two overlapping cylinders with an arrow, indicating that we are now connected to an extract as opposed to a live connection. There are several extract-related options available in the drop-down menu of the data source. If I click on it, you will notice that Use Extract option is selected. If I uncheck that, you will notice that Tableau went back to using a live connection denoted by a single cylinder. If I check this option again, Tableau went back to two overlapping cylinders with an arrow. In the Extract option, you have the ability to refresh your data, add or append data to an existing extract via a file. If you have calculations in your extract, you can compute the calculations. You can see history of extract refreshes, Or you can see extract properties like storage, aggregation, filters, limits, type of extract, and what version of extract you're in. You can also completely remove an extract and revert back to using a live connection. So that is how you can create, store, and use data from an extract in Tableau.